Okay, all right. Well, happy Wednesday, everybody. I hope things are going well. I hope by now we feel okay. I hope our Git is working. I hope our Python is set up. I hope everything. Again, I mean, your first homework is coming up. Is due in a couple days here. So if things aren't working, make sure you come to office hours, and we'll try to get everything up and running and working. But yeah, it's getting late. So again, hopefully by now you're comfortable with the idea of pulling things from GitHub, from Git. And so for me, I change into my directory, 2024 fall stats, whatever, and then if I list off what's in there. Actually, I'm only up through 2-1, and so what I want to do is I want to pull. I'm going to do git pull upstream main, and you got to do this every time. Okay, it's not an automatic thing, but then once you do git pull upstream main, all of your files should be updated. You should now have 2-2 with flow control and lists, and you can open that up and follow along in today's lecture. So that's what we have. All right, and so today we are going to look at lists. Well, first, flow control. So things like how do you control the flow of the program, right? And kind of the primary thing that we use are conditional statements, okay? And that's done with if, else if, and else, okay? So this is kind of your basic statement. Is the conditional. As far as conditional things, there's a few things about Python that is different from some of the other languages. No need to use parentheses. You just say something like if x equals 0, okay? To end your conditional statement, you use a colon. When you enter a colon, Jupyter, VS Code, it's smart enough that as soon as you hit enter after you enter a colon, it's automatically indented. Okay, and that indentation means these are the lines of code associated with that conditional statement. So this line right here, print x is 0, is associated with the previous line. Yeah, question?
How do we prevent like a hanging else? Can we bracket things still?
No, there's no brackets. Everything is done with indentation. So you either indent it or you don't indent it. And again, it feels a tiny bit strange, but it makes it forces your code to be at least have a certain level of readability. Because I don't know if you've ever read someone's bad code where they didn't indent any of their their code blocks or things like that, and it's like very frustrating to read, to have to read somebody's code that hasn't been indented. Okay. So lines that are indented after the colon are associated with that if statement. When there's no longer indentation, that's no longer associated with the if statement, okay? The else and the else ifs, those have to be on the same level of indentation, okay, as the original if statement for it to kind of work. So here, I'm going to assign the value -3 to the variable x. And then I run these lines of code. I'm going to say if x is equal to 0, print x is 0. Otherwise, check to see if x is greater than 0, and then x is going to be positive. And if that is not true, then print x must be negative. So I run this, and it says -3 must be negative, and that is true. Okay. Here. I have if x is greater than 0, we'll print x as positive. And then here I have an else if. And it says else if x is greater than 3, print x is greater than 3. Now, this line of code, print x is greater than 3, will never get executed because there's no situation where this statement, x is greater than 3, is true, but while this statement is false, okay? So whenever you have an else if, this else if is only going to be evaluated, only going to get checked if the previous if statement is false, okay? So if I have x is equal to 100 and it says if x is greater than 0, it's gonna execute this line, x is positive, and then it's gonna skip the rest of this whole entire if, else if block, because the else's only get checked when the if is false, okay? So it's gonna be like, if this is the case, then do this. And if it is, you go down that path, and then you're at the next kind of stage in the timeline or whatever, okay? And it's only if that initial thing doesn't work, then you check the else's, okay? You check the else if, and then if that's not true, then you go to the else, okay? So the else if here is only evaluated, okay, when this thing is false, okay? And in fact, you could put in a statement here that's complete nonsense, okay? Like something that would result in an error, and Python doesn't even look and evaluate it, okay? It's not even going to evaluate whatever we put here because it doesn't care, right? It doesn't matter that there's a problem there because it just doesn't even look at it, okay? So Python is the design philosophy of Python is that it is lazy, okay? And we often think lazy is like a bad trait, okay? But the flip side of lazy is that it's efficient, right? You're not going to waste. It's not going to waste time doing things it doesn't need to do. So it's if it doesn't need to evaluate something, if it doesn't need to use your computer to kind of calculate some result, it's not going to until you kind of force it to. And so that's kind of Python's design philosophy. Okay, you can have nested conditionals, right? So after one if statement, you indent, and you could put another if statement in there. And so first it's going to check this if statement, and then it'll evaluate this if statement. And if you want to have something there, then you can have it evaluate there, right? So here I can have x is equal to 5, and we can say if 0 is less than x, then evaluate the next thing if x is less than 10, okay? And you can do either 0 is less than x or x is greater than 0. Either, that could have worked fine, okay? And here it says x is a positive single-digit number. I guess assuming I should say if x is an integer somewhere in there, okay? In general, the recommendation is to avoid nested conditionals. It's better to just use an and statement, okay? And so in Python we use the word and, okay? And so we'll say if 0 is less than x and x is less than 10, then you can do this, okay? And then Python has enough kind of ability to kind of do kind of this inline form where you can do 0 is less than x is less than 10, and this will also evaluate. And Python is able to interpret and parse this correctly. So you can do it this way. But a lot of times, if you have some kind of conditional statement that you need evaluated, you can just use the word and here. Okay. Later on, we will. So all of these things are what we say is not vectorized. Okay, we're expecting just basically one kind of Boolean value here, a true false. 0 is less than x is either going to evaluate to true or false. X less than 10 is also going to evaluate to true or false, and we're expecting just one of these things. Later on, when we encounter, say, NumPy, we will have arrays, and you can have kind of these vectorized comparison statements where you can take an entire array and you can compare it to, you have a value 1 through 10, and you compare it to, say, is x less than 5, and it's going to give you true for some of the values and false for some of the other values, okay? Those kinds of statements don't work with these traditional if conditional statements, where here we're just expecting basically a single Boolean, the condition, to evaluate to just a single Boolean yes or no, true or false. We have recursion, okay? So recursion is kind of a little bit of an odd concept in kind of programming in computer science, but this is at its most fundamental level, this is what is required in order to kind of have I guess like a Turing complete language. All right, in order to, you need to have some ability to kind of repeat the same thing, and at the most basic level, it's done via recursion. To make languages easier to think about and implement, we can have for loops and while loops and things like that. But you can have a language that works perfectly fine without any for loops or while loops, using recursion only. It would be a little bit hard to kind of work through, but the idea with recursion is that you have a function, and the function makes a call to itself inside the function. So basically, it's saying, when you encounter this line of code, just call the function again. Okay, and so this requires you to have a base case so that it doesn't do recursion infinitely. If you don't have a base case that kind of stops and doesn't call itself, then your recursive function will kind of go infinite, will run forever. And so in this case, we're going to have just a very, very simple function. It's going to be called countdown. We put in some value n in some integer. And the base case is that if n is 0 or less than 0, then we're going to stop. We're going to just print the word blast off, and then and that will be it. Okay, that's going to be the last thing it does. Okay, but if n is anything other than 0, if something is something greater than 0, then we will print out that value n, and then we will call the function countdown recursively on the value n minus 1. Okay, so that's going to be our function. So when I call countdown on 3, okay, when we first evaluate it, okay, we're going to start with n equal to 3. It's going to look at this first if statement. N is going to be greater than 3, so it skips over that, and it's going to run the else part. Okay, it's going to print 3, and then recursively, it's going to call n minus. It can call countdown on 2. Okay, and then so when it calls countdown on 2, again, it skips the if statement here because it's not true. I mean, it evaluates if n is less than or equal to 0. That's false. So it comes to the else. It's going to print 2, and it's going to call countdown on 1. And then when it countdown 1, it's going to basically skip this part. It's going to print 1. And then it's going to call countdown on 0. And then when it calls countdown on 0, then it will print blast off. And that's the end of the function. That's the end. So that function returns, and then it returns to basically, it feels a little bit silly, but it goes back to countdown 1, and it says, okay, that's done. Then countdown 2 is done, and then countdown 3 is done. So when I evaluate this, we're going to get 3, 2, 1, blast off there. Okay. Yes. Question.
So if you were to put like a line of code after all statement, like the if else statement,
yeah,
then it would run at the end.
Yeah. So I can do print end of function. Okay. So I can do this, and then so it'll do 3, 2, 1 blast off, and then and now that it has finished running this, it recursively calls all of these things here. I can actually do print end of function, and then the n that was there, and so you'll see it count back up. Okay, so it calls countdown. It's going to call countdown on 0, right? On countdown 0, it calls blast off, and then when it returns, it's going to print out end of function 0, and then it returns back, and then it says, okay, well, we finished countdown 1, so it's going to print end of function 1, and then it returns that, and it climbs back up. Yeah, so the recursive thing kind of goes down. Yeah, this is probably actually more helpful as far as understanding exactly what's going on in the recursive thing. So again, I don't like to update just to avoid merge conflicts, just so you can like make your own edits, but it might not be a bad idea to just kind of add this line that says print end of function n here, and you can kind of see how the countdown that got n equals 1 returns, and it prints all of these things out. Okay. Okay, so here is just kind of a dumb thing. This is going to print a string n times, okay? And so we're going to say if n is less than or equal to 0, then return none and exit the function, okay? Otherwise, print the string, and then we're going to recursively call print n, n minus 1 times, okay? So here we're going to have hello, and then so prints hello, 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 okay? And again, I can change this to 10, and it's going to print all of these things. And then again, on any of these things, I could just print end of function with the n. See, and you can see kind of how it recursively goes back. Okay. So this is print start of function with the n, and then here we can just do print 3. Okay, so start of function 3, hello, and then it makes the recursive call, and then when it hits start of function 0, it returns none, and then once it is done, it returns the end of function. So you can see all of these things, how it works there. Okay. Mathematically, we have the factorial function. The factorial function is basically a recursive function because 4 factorial is 4 times 3 times 2 times 1, which is really just 4 times 3 factorial. And 3 factorial is just 3 times 2 factorial, so on and so forth, okay? And then your base case is 0 factorial being 1, okay? So, so as far as this goes, if your n is 0, you're going to return 1. Otherwise, you're going to return n times factorial of n minus 1. Okay, so you can get that, and indeed factorial 4, factorial 5, you get exactly what we expect with our factorial functions. Okay, let me give you your first view quiz answer. To look this up. First answer today is the letter A. A as in apple. Okay. So technically, you can perform any kind of repetition that you need with just recursion only, okay? But our life is made a lot easier if we have something like a for loop, okay? Or a while loop or something like that, okay? And so one of our most basic loop types is the for loop, which basically just repeats the same chunk of code, okay? This code block, it gets repeated for every instance in an iterable. So in Python, you have something called an iterable, and that could be a list, it could be a string, it could be a tuple. A dictionary is also iterable, and it's basically something that's going to an object that consists of sub-objects, right? So a list contains different objects in here, all right? And so you can do it for the first element of the list, then the second element of the list, and the third element of the list, and so on and so forth. So here I have a list called values. I've got the values 5, 7, 2, and 1. And then I also have just a separate variable called y. And then we're going to say for each item in values, so for x in values, we're going to repeat this thing. We're going to print out whatever that x is. So we're going to start off with 5. We're going to print out 5. Okay? And then we're going to take our y and we're going to add x to it. So the y plus equals x is the same as taking your current value of y, adding x to it, and assigning it back to y. So we're going to take 0, add 5 to it. Y is now going to get updated to 5, and we're going to say our running sum is 5. Then we move on. Once it reaches the end of the code block, okay, then the for loop says, okay, now do the same thing, but for the next item. So we're going to go to 7, and we're going to print out 7, and we're going to add 7 to our total. So y is currently 5. We add 7, we get 12, and it's going to say running sum is 12. And so, so this is what we get. We get 5, running sum is 5, 7, running sum is 12, 2, running sum is 14, 1, running sum is 15, okay? So you have that, right? A string is also an iterable. The elements in a string are basically the individual characters. So here I'm going to have this string UCLA space UCLA, and we're going to say for each character, so for A, so here, but basically the A is a stand-in for each character. So when we first run it, it's going to be the letter U, and it's going to do A dot upper. So it's going to take the uppercase U, tack on an exclamation point, and print that out. Okay. Then it's going to go to the next. Once it's done, it goes to the next item in the iterable, which is going to be the letter C, lowercase c. It's going to capitalize it, uppercase C, tack on an exclamation point. And then so, you know, feels like we're cheering, okay? And it also does it for the space, so you get a space with an exclamation point. I don't know what that sounds like, but this here, you go through each letter there, okay? So in Python, you have a variety of objects that are iterable, which basically just means you've got items within that object there. Another iterable object is known as the range object, okay? And this is useful if you just want to kind of create a sequence of numbers. So if you do something like range 10, it's basically creating a sequence from 0 through 9, okay? You're creating a sequence of length 10 starting at 0, okay? So range 10 basically creates a series of indexes that is 10 items long starting with 0. The general format of range is going to be range. You can put in 3 arguments, start, end, and step size. If you don't specify, if you just provide it one value, like range 10, it's going to assume the default value start is going to be 0 and the step size is going to be 1. Okay, so range 10 will create a range 10 object. So starting at 0 and going through 10. And again, Python is lazy. So even when you say range 10, it's not going to create the integers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's just going to say, oh, you want a range object of length 10 starting at 0. And it just stores that. And then when you ask it, hey, what's the number I need? It's going to say, oh, the first number you want is 0. Oh, you want the next one? Then it's going to be a 1. And the next one is going to give you a 2. And so that way you can say something like range 1 billion, and it's not going to bother writing out 0, 1, 2, 3, 4, 5 all the way up to a billion. It's just going to say, you want a range object of length 1 billion? That's fine. Just when you're ready and you want me to give you the next value, ask me and I'll give it to you. But I'm not going to bother wasting computational time figuring out all 1 billion numbers until you actually ask me for it, okay? So here we're gonna say, hey, range 10, I want you to actually give me the next value. So we're gonna say for each number in range 10, print out the I, and then put a space after it. The normal end character for print is a new line, but here we're gonna just put a space so it stays all in the same line. And so it says, okay, fine, 0, what you wanted the next number 1, you wanted the next number 2, you wanted the next number, and it goes all the way 0 through 9. So it has no problem giving us all of these things. But again, when you first tell it to create a range object, it's lazy, and it just says, yeah, I will give you a range thing, okay? Range 5, 10 will start at 5, but go up to not including 10. So So here, again, it just produces the range object. Lazy, doesn't evaluate it. If you throw the range object inside a list, okay, a list is the command to create the data structure list. And so a list says, I need all of those values and I need to put them in a list. So this is going to force Python to evaluate the entire range object. So here we're going to get 5, 6, 7, 8, 9. Okay? So you have your start and your end, and traditionally it's not going to include that end number. So it goes 5, 6, 7, 8, 9. It doesn't go up to 10. Okay? Here I'm going to do range 0, 22. Step size is 2, so we're going to start off at 0, and we're going to go 0, 2, 4, 6, 8, and it's going to stop at 18. Okay? Goes up to, but doesn't include that kind of last thing. Now, if I do range 0, 21, 2, then it will go to 20, and then and it stops there. Okay, so it feels a little bit, if you're not accustomed to it, some of these things might feel a little bit strange, but this is just the rules that Python does. Now, Python gets angry if you try to give it something that's not an integer. So if you say range 0, 20.1, okay, and then it's going to say no. All right. Floats cannot be interpreted as an integer, right? So 20.1 is a floating point number. It's got a decimal place. It's going to say, I don't like that, okay? You can also specify a negative value for the step size, and it will count down. So 10, 5 will go 10, 9, 8, 7, 6. Again, doesn't include that last number, okay? If you don't include the -1 here, and if you just say range 10, 5, then Python says no, okay? It gives you nothing, right? It says, starting at 10, ending at 5, there's no values in that range there, okay? So that's your range object, and that's going to be, you're going to see that very frequently, especially just something like range 10, range 100, to kind of give you values from 0 through 99 or something, okay? Another kind of loop is the while loop, and this basically combines a conditional, and it's going to say as long as this condition is true. So on the while statement you have this conditional statement, and as long as that statement is true, run all of these things, right? We're familiar with while loops, I think. So here I'm going to say while I is less than 10, print I, and then increment I by 1. So we start off at 0, and it gets up to I is 9, okay? It prints out, at 9, it prints out 9, and then increments I becomes 10, and then when I is 10, this is false, so the loop stops. So if I ask Python, what is the value of I at this moment in time, I has the value of 10, okay? And that's why it didn't run, because that statement was false. Okay. We also have these statements that control how loops run, and we have the break and the continue statement. Okay, break statements will break the loop, break out of the loop. So the loops will kind of continue to run and repeat itself for as long as the while statement is true, or it will repeat itself through all of the objects in your iterable, whatever it might be, if you have a for loop or something like that. But break is going to just say, hey, you know what? This thing where you're repeating it, just stop. Okay, just stop repeating it and move on to the rest of the code. Okay. Continue says this current iteration, stop the current iteration and move on to the next iteration. Okay, so that's what it is. So continue skips the remainder of the current loop, the current iteration, and just goes on to the next one. So let's take a look at what this does. So we're going to say for n in range 20. So range 20 is going to go 0 through 19, 0, 1, 2, 3, up to 19. And we're going to say if n mod 2 is equal to 0. So that basically means if n is an even number. So this is kind of I guess a shorthand, or the idiom that we use to check if something's an even number is we do n mod 2 equal to 0. And if it's an even number, we're going to continue. Okay, so that means ignore whatever lines of code come after continue and go to the next loop. Okay, if we don't ignore the lines of code, we're going to print n. Okay, so what is this going to look like? Okay, so when we start off, n is 0, and 0 mod 2 is 0. Okay, so we're going to click continue. We're going to hit continue, and we do not execute this line of code. All right, at the next iteration, n is 1. When n is 1, this is false, so we do not encounter the continue, and we instead encounter this line that says print. So we're going to print 1. Okay, now we've naturally hit the end of the code block, and so we go to the next iteration. And now n is 2. Okay, at 2 we're going to encounter the continue, so we don't run the print statement, and then we go to the next iteration. N is 3. At n is 3, we do not encounter continue, but we hit the print. And so what's going to happen is we're going to end up printing all of the odd numbers 1, 3, 5, 7, 9 up through 19, and every time we hit an even number, we hit that continue statement, and we go to the next iteration. Okay. All right. Here is, there's hundreds of ways to write code to create a sequence of Fibonacci numbers. Okay. So Fibonacci numbers is, you take the two numbers. You start off with 0 and 1, and you add 0 and 1, you get 1, and then you take 1 and 1, and you add those two together, you get 2. And you basically take the two previous numbers to get your next number. Okay. So here I'm going to start off with a is 0 and b is 1, okay? And so notice I can use Python's tuple unpacking and tuple assignment here, which is really nice, right? So I can take 0 and assign it to a, and 1 and assign it to b, and I can do that in one statement. And we're going to have a stopping value, a maximum, okay? And I'm going to start off with an empty list, okay? So here, square bracket, with nothing inside, we'll create a list, but with nothing in it. And while true just means run forever, okay, until you encounter a break statement. So while true is gonna run forever, and the only way you're gonna quit out of this is gonna be with a break, okay? And so I can create my Fibonacci sequence by basically taking B, assigning it to A, and then we're gonna take A and B, and assign it to B. Okay, so here I'm basically doing evaluating a new number and then using kind of tuple unpacking, and so B becomes the new A, and A plus B becomes the new B. And then and we're going to check to see if A has exceeded our largest value, and if it does, then we will break. Okay, otherwise we'll take that value A and append it to our list. We're going to do l.append. Okay. And then so at the end, after this loop has finished running, we'll print out L, and we get basically Fibonacci sequence. Okay, 1, 1, 2, 3, 5, 8, 13, 50, 34, 55, 89. Okay. So we have that. Okay, let me give you your next VQuiz answer, the letter B. B. Okay, so all of our conditional statements, anything that goes in an if statement, else if, while, all those conditional statements, we need Boolean expressions, so basically just true or falses. And so we have a whole bunch of comparison operators, so I'm just going to fly through these. You have check for equality, equals sign, okay? That's going to be true. 5 equals 6 is false. Exclamation equals is not equals, so that 5 is not equal to 6, that's true. 5 greater than 6 is false. 5 less than 6 is true. 5 greater than or equal to 6 is false. 5 less than or equal to 6 is true. Okay, what about string 5 equal to integer 5? Okay, that's false. Okay, so this is a comparison to see if these objects are equivalent in value, and they are not. The string 5 is not the same thing as the integer 5. Okay, now you can also use greater than or less than operators with strings. It's a little bit confusing, but it's like doing alphabetical order, and it feels a little bit strange, but things are in alphabetical order, and all capital letters come before all lowercase letters, which also feels strange, but capital A comes before lowercase a. Capital Z comes before lowercase a, okay? Obviously, lowercase a comes before lowercase z, so these are all, okay? You have the and the or operators that combine Boolean statements, and so true and false. I think we're familiar with all of these things, right? True or false is always gonna evaluate to true. Not true is false. Not false is true. False or not false, okay? That's going to be true because not false evaluates to the true. So you have a false or true. True and not false is still also going to be true because not false is true. To check if x is divisible by y, you can do this. So you have x mod y. So here I've got n is 6, is n divisible by 2 and n divisible by 3. That one's going to be true. Okay, what about 8? That's false. If you do an or, is 8 divisible by 2 or divisible by 3, then that's going to be true. So all of these are Boolean statements that evaluate to true or false, and we can use the ands and the ors to combine them. I have this segment here that says a little bit on strategies for writing functions, okay? And so, when you write a function, and, some of you already started writing functions and things like that, I always advise against just straight up starting to write a function. So your first line shouldn't be define, function name, and this or that. And that's because if you encounter problems, inevitably you will, it's difficult to figure out what's going on. So first, just try to get your code running, not as part of a function, okay? And then once you get your code running, then you try to put in little placeholders for variables, and then you can encapsulate that into a function. So here is, just imagine giving, instructions to, there's something called Turtle Graphics, but basically instructions to a little pen where you're going to say, hey, go forward, and then turn left 90 degrees, go forward 100 spaces or whatever, turn left 90 degrees. And if you do this and you repeat this 4 times, you would get a square, right, where each side is, 100 pixels long, okay? And you can do that. And we can take this and we can encapsulate it, basically take the stuff that gets repeated and throw it into a function. So we can create a function that says define, called draw a square. And we're going to just kind of repeat that thing where we say, hey, go forward 100 and turn left 90 degrees. And we're going to repeat that 4 times. So we're going to say for I in range 4, okay? And basically, it's going to repeat it 4 times, 0, 1, for I, 0, 1, 2, and 3. And we're going to call that drawing a square. Okay. We can generalize this, and rather than saying we need every side to be 100 pixels long, we can just replace that with some variable like length, okay? And we can put that into one of the arguments for this, okay? Let's see, hey, draw a square with length this, and we'll do that, okay? If we want to generalize this even further, and we say, hey, what if I want to draw things other than squares? If I just want to draw like a regular pentagon or a hexagon or something like that, okay? How much does the thing need to turn, okay? And it turns out that the angle that you need to turn is going to be basically at the end of the whole thing, you're going to have gone around 360 degrees. So the angle that you need to do each time is just turn 360 divided by however many angles you're going to be making. Okay, this is not the interior angle, but just kind of like if you're going straight and you need to turn left or right, whatever it might be. Okay, so this is to generalize, and so you can say, hey, we want to create a polygon where you want n sides, and so your angle is going to be 360 over n, and then you're going to repeat this n times. You're going to go forward the length, and you're going to turn left the degrees of the angle there. Okay, so that's just a little bit of just kind of basic strategies as far as approaching a function. Start off with basic code, not part of a function, and then once you get it running, then you can start thinking about wrapping it up inside some kind of function with variables there. Okay, let me start talking about lists, and we're going to have to continue talking about lists in our next lecture as well. But lists are an important data structure. They are iterable data structures, but they allow us to kind of mix different data types, and you can also include lists inside other lists. So here is a list of, I guess, people's names and maybe their heights. And so this is just some fictional family. Okay, and we're going to call this list fam. And we're going to put in the names Liz and Emma, mom and dad. We're going to put in the floating point numbers, 1.73, 1.68, 1.71, and 1.89. Okay, and so you can mix different types of data. And when you do this, you just create a list there. Okay. Here I've got another list, fam2, and this is the list of lists, okay? And you can see that we have two sets of square brackets, okay? We have the opening square bracket. So the top level list is a list of length 4 items, and each of those items themselves is a list of length 2. So the first sub list, I guess, is a list with the name Liz and the float 1.73, okay? And so when we ask Python to just kind of tell me what these things are, and if I say, hey, what is fam? It prints out the entire list. If I say, what is fam2? It also prints out the list, and we can see it is a list of 4 lists. Anytime you want to refer to an object within a list, you can just use the square brackets, the name of the list, square brackets and an index, and it will tell you the value of the item in that index position. So one thing to have to remember is that in Python is 0 indexed versus R, which is 1 indexed. And so the first item in a list is position 0. So fam position 0 is going to be the string Liz. Okay. Fam2 position 0, okay, is going to be the length 2 list containing Liz and 1.73. Okay. Now, if you want to get the string Liz from fam2, you can say fam2 item 0, and within that, item 0. Okay, so square bracket 0, square bracket 0, and that will give you the string Liz there. You can also provide negative integers. If you provide negative integers for the index, it will count from the end. So negative 1 will count from the end, and we will get 1.89. Okay, so counting back. Okay, same thing with fam2. Negative 1 will give you the last item there, so that's going to be dad 1.89, and then negative 1 will give us that value 1.89 there. If you want to select multiple items from a list, okay, you can slice the list. And you slice the list by providing basically 2 integers, 2 indices, and you put a colon between them. And you can kind of think of the slice corresponding to the comma appearing at that position. So when I do, so if this is my list fam, and I say slice from 1 to 3, okay, here basically I look at my first comma, which is between Liz and 1.73, and then the third comma is between Emma and 1.68, and so what it slices out is going to be basically 1.73 and Emma. It's going to give me the sublist there. Okay, so the slicing, you can imagine, happens at the commas. So here, if I do 1:2, we're going to just get out the value 1.73. Okay, we're going to get back the list containing the value 1.73. That is, there's a distinction between asking for the list with square bracket 1. Okay, so slicing from 1:2 gives you back a list containing 1.73, and then slicing and just saying, hey, give me the object at position 1 gives you just the value 1.73, right? So if I asked type of FAM, what is this thing? That's going to be a list type, whereas if I say what's the type of this is going to be a float, okay? So this is a list containing just 1.73, and this is just the floating point number 1.73, okay? If you say FAM 1:1, if you try to slice from 1:1, okay, there's nothing there, so it's going to give you back an empty list, okay? Give you back an empty list. Okay, 0:2 will give you up to the first two elements. Okay, and you can also say 6 through 8, and that will give you, if your list is of length 8, you know, it'll give you the last two from 6, 7, and 8. Okay, so that's what you get. If you just want everything through the end, you can just provide a colon and nothing after, and it will give you from basically element 2. So you know, I could just do from 6 to the end, okay, and that will give me the kind of the equivalent. I can basically say from 0 through 4, or nothing through 4. So you know, stating 0 through 2 is the same as just saying nothing through 2. So that's what you have. And then if you do, if you just do a slice with nothing. Before or after the colon, then it will just create a copy of the list. Okay, so this creates what's known as a shallow copy, but basically you're just saying, hey, start at the beginning all the way to the end. You're slicing out the entire list, and you get an entire copy of the entire list. Okay, if you don't provide any indexes inside the square bracket, then Python says, you know, Python doesn't like that. That's going to throw an error. Okay. Okay, we'll get through here, and then we'll call it a day. All right. So here you can also provide negative indices to slice. So if I say -5 through -2, you know, counting backwards, 1, 2, 3, 4, 5. Okay, we're going to go from you know, 1.68 to -2 to 1.71. All right. So counting backwards, this is what we get. Providing negative indices. Here I have, again, FAM2 is the list of lists, and you could say, okay, colon 1 through 3 is going to give me a list of these two elements here. Again, a list of lists, but containing these two things, right? All right, so what is this going to give me? FAM 1:3, 0, 0:1. Okay. So 1:3 is going to give me this thing. Colon square bracket 0 is going to give me the first item there, index 0 position, and then 0:1 is going to subset that, and we're going to basically just get the Emma out of that, right? So so that's what we get there. Okay, we'll call it a day here. I gave you 2 answers so far. Okay, I'll give you your third one, and